Alright, so I am going to move my mic closer, and I'm going to make a what I hope is a fairly short video, but there's going to be a lot here, so I'm going to go kind of fast. But we're going to start with something called the unit circle. Now, when you get into geometry, or I know trigonometry, you will definitely talk about the unit circle. You may talk about it a little bit differently. I claim to be no expert on the unit circle. I'm just going to do my best. So we'll assume this is center. It may not be. But the unit circle basically is this. It is a circle whose radius is from the center point to the outside of the circle, is equal to 1. The radius is equal to 1 by definition. So that's what the unit circle is. Now, if we measure angles in two different ways. There are degrees and there are radians. I'm going to talk about degrees. Radians are useful. There's another way of measuring it, and I believe that 2 pi radians is equal to 360 degrees. So there's kind of a ratio there, but we're going to talk about degrees. So this is going to be considered, this vector here is going to be considered to be 0 degrees because, well, it is at 0 relative to the positive x-axis. This would be 90, this would be 180, 270, and back to 0, or 360. Alright, great, we know this. Now, let me go ahead and make a couple points for you. This point here. This is at 90 degrees. Obviously, this is a coordinate, right? I could tell you the coordinates x comma y. Well, the x value is, it's not any, so it's 0, comma, let me switch to my actual pen so I can write better. So you have 0, comma, the y value is 1. I know it's 1 because it's the unit circle, and that's on the edge of the circle, so it's equal to 1. At this point, I'm going to go over this faster, -1, 0. You can figure this out. 0, comma, -1, and this point is 1, comma, 0. These will become important in a minute. Now, let me show you this. Let's put an arbitrary angle. I don't know what this angle is. I made it up. And we're going to say that this angle has a measure of theta. Theta is this angle. Okay? So again, we don't know what it is, but we know that it's theta. We do know this. We can draw a triangle from this, right? In other words, think about this as a vector. We can break up this vector into two components. We'll have an x component that would go out to like here, right? This is the x value. And we have a y component, which I could draw starting from here, but I'm actually going to start from here. Now this should look familiar because this is how we like add vectors graphically. And we have this component. So we have theta. There's also one other thing that we know about this triangle. And hopefully you know what it is, right? This side. This side of the triangle, or the vector, is 1. How do I know that it's equal to 1? Well, because it is to the radius. And this is my unit circle, so of course it's equal to 1. Alright, let's try to figure out what we can about this side here. Now, in terms of our trigonometric identity, or, well, we are going to talk about trig identities, but like the sides of the triangle. This would be the adjacent, hypotenuse, and opposite. So this is the opposite side. Well, what do I know about the opposite side? I have this equation that says that sine theta equals opposite over hypotenuse. Well, if we plug in everything that we don't know theta. We're going to assume it's some angle, though. So we'd have, this turns into, for this, sine theta equals opposite, which we don't know. Let's call it y, over the hypotenuse, which I do know. The hypotenuse is equal to 1. So what do I have here? I have that this side, if I say this is y, is actually equal to sine theta. Okay. What about this x side? Well, I could do the same thing with cosine, and I'll do that real quick. Cosine theta equals adjacent over hypotenuse. Ka. Remember, so ka toa. Okay, so cosine is adjacent over hypotenuse. Well, in this case, this is going to clean up to look like this. Cosine of theta is going to be, now the adjacent side, I don't know, I'm going to call it x. So we'll call it, instead of writing adjacent, I'm going to write x over the hypotenuse is still 1. So we have x is equal to cosine of theta. And so we have this point here. I'll put it in green. This point. This is the point where this meets the circle. That point has two coordinates, an x and a y coordinate. The x coordinate is going to be equal to, well, let's see what the x coordinate is. Well, it's whatever this red part is, right? Because that's how far away it is. Well, the x coordinate is actually equal to cosine theta. So if I was going to write the coordinates for this, it would look like this. Cosine theta. I'm afraid I'm going to run out of space. I'm going to move this over real quick. Again, nothing is really changing. I'm just going to put it down here. So we have cosine theta, comma. Okay, well, that's the x value. What's the y value? Well, the y value is going to be, look here, it's sine, right? Because it goes up that far, so it's sine theta. So the coordinates for this point are cosine theta, comma, sine theta. Well, that's pretty interesting. Cosine gave me the x value, sine gave me the y value. What I've just determined is I can now know what this point is. The cosine and sine are kind of the x and y coordinates. That's actually another way to define cosine and sine. If I change this angle all the way over here now, cosine would represent the x coordinate. Sine would represent the y coordinate. You can see cosine should be negative. In fact, I guarantee if you take, I don't know, let's say this angle is, it's bigger than 90, right? Less than 180. Let's say it's 110. You take the cosine of 110 right now, I guarantee you'll get a negative answer because it should be negative. It's a negative x component, and the y component should be positive. In fact, once you see that, you can now understand a lot easier. Okay, let's look at 90 degrees. Right? Remember your cosine of 90, all you gotta do is it's 0. How do I know it's 0? Well, you can punch in the calculator and see, but look, it is 0 because the cosine represents the x coordinate and there is no x coordinate for this straight up angle. It's 90 degrees. However, the sine, the y coordinate is going to be represented by the sine. If you type in sine of 90, you get 1. And so you can now see why, okay, the cosine, you know, I used to think, oh, it's kind of weird. When I was a kid, I was like, cosine 0. Why is anything of 0 not 0, right? Because, you know, the cosine 0 is equal to 1. Well, why is that true? Well, let's look at it. 0 degrees. You have 0 degrees here. What is the cosine represents the x value? It's 1. So that's why it is. Also, tangent, right? This can help us understand tangent. We don't talk about tangent very much, but it is, you know, important. The tangent equals opposite over adjacent. So the tangent at any degree, at any angle, the tangent's going to be equal to the opposite over the adjacent, or in other words, whoops, I kind of messed up here. The adjacent was the cosine, the opposite was the sine. So in other words, it's going to be the sine over the cosine. Sine over cosine, or y over x. So in terms of x and y coordinates, the tangent is going to be equal to y over x. So now you see why tangent is undefined in so many places. Look. Let's look at the tangent of 0, right? The tangent of 0 degrees is going to be y over x. So you have your y value, this one, over your x value. You get 0. You can plug that into the calculator. It should tell you that. But look at the tangent of 90 degrees. It's y over x. And now you've got the y value is 1 divided by the x value is 0. Well, that's why it's undefined, because you can't divide things by 0, right? They approach infinity. They become unwieldy once you have that. And that's why. So again, I just wanted to give you a deeper understanding of what sine, cosine, and tangent are. Another way to think of them is sine and cosine. So again, if I pick an arbitrary angle, I know this is some large angle, maybe it's 200 degrees. Well, again, sine is not, you're asking, how does the calculator figure out sine? Well, sine represents what is the y point at this coordinate. What is the y value? And you can tell that even if I don't know what it is, it's going to be negative. It's going to be less than -1, but it's going to be negative. And what is the cosine represents the x value, which again is going to be negative. All right, so that's all I wanted to show you. Hopefully that helps you understand a little bit better.